of the session. Now, I would like to hand over the session to Dr. Meenakshi Tripathi, coordinator of this faculty development program on machine learning and artificial intelligence, to enlighten and introduce our eminent speaker. Thank you. Dr. Meenakshi.
Thanks, Dr. Sushant. Good evening to everyone present here, and thank you for joining us at this 2-week FTP sponsored by the Atal Academy. I am the co-coordinator for this course. It's my pleasure to inform you that we have got excellent speakers from across the country to share their valuable knowledge on artificial intelligence and machine learning with us. And it's our honor to have Professor Ganpati Panda with us as the first speaker. We welcome you, sir, for this FTP. Now I request Ketki to introduce sir to the participants, and I wish a very happy learning to all the attendees. Ketki.
Thank you, ma'am. Now I'd like to introduce Professor Ganpati Panda. Professor Ganpati Panda is currently working as a professor and research advisor at C.V. Raman Global University, Bhubaneswar, Odisha. Professor Panda served as the Deputy Director, Dean Academic Affairs, and Head of School of Electrical Sciences at the IIT Bhubaneswar. He also was Dean Administration, Head of Electronics and Communication Engineering at the National Institute of Technology, Rourkela. He was a member of the Board of the Governors of IIT Bhubaneswar and NIT Rourkela. Dr. Panda also served as Director of the National Institute of Technology, Jamshedpur. He worked for 48 years in teaching and research in leading technical institutions in India. He did his postdoctoral research work at the University of Edinburgh, UK, and PhD from IIT Kharagpur in digital signal processing. He has published more than 380 research papers in various referred journals and conferences with 12,139 citations, H-index of 53, and I-10 index of 181 as of 6 January 2023. He has received Samanta Chandrasekhar Award in 1993, Biju Patnaik Award in 2012, INAE Outstanding Teacher Award in 2017, AICTE INAE Distinguished Visiting Professorship 2019-20, and AICTE Margadarshak 2019-20, Lifetime Achievement Award, Ravenshaw University 2021. He was listed under top 2% scientists of the world from the Stanford University in the area of AI/ML 2021-2022 for his significant contribution to engineering, education, and research. His name is included in the Technology Advisory Board of the Center for Development of Telematics Government of India in March 2022. Professor Panda is listed as one of the world's best computer science scientists in India by the Microsoft Academic Graph in the year 2022 with a national rank of 33. His research interests are in the areas of artificial intelligence, machine learning, digital signal processing, digital communication, and intelligent instrumentation. So we are lucky to have Dr. Panda today with us. Now I'd like to request Dr. Panda to start today's session. And I have a request to all the participants that we have an interaction session at the end of this lecture series from 9 o'clock. So you can note down your questions and ask in the interaction session. So I'd like to request Dr. Panda to continue with the session.
Thank you for introducing me. Good evening to all of you. Thanks to Director Professor Padi, the head of the Department of Computer Science and Engineering, Meenakshi and Susan. Thanks for giving this opportunity. My talk will be split into 2 halves. First half 50 minutes, there is a gap, another 50 minutes. I will talk on very simple and fundamental way. those who are starter, those who want to pursue their research work will be immensely benefited from my lecture. After this 2 hours talk, I think you can able to understand when other speakers will speak on some particular topic in depth. With this little introduction, I am displaying my slides and start my lecture. Give me 30 millisecond time. Yes. I think is my first slide. Is visible to all of you. Are you able to see my slide? Somebody should respond.
Sir, we can
Is it
see you,
visible?
but we can't see your slides actually.
Is it clear?
Shashwat or Shubham, please respond to sir. I'm not able to see the slides actually.
Yes, sir. So your slide is not visible, sir. Share the screen.
What's the issue coming, sir? Yes, sir. Now your slides are visible.
Yes. So let me start. The theme of my talk is very fundamentals of machine and deep learning techniques. And I will highlight various applications which are being used today in practice. Let's see with this small introduction, my first slide, the outline. Yeah, the outline of my talk are this following. I will tell what is the fundamental of the raw data. Then what are the various states for analyzing the data? Then what are the different, this is most important, types of decision, types of operation and actions. Everybody talk of data science. Everybody talk of machine learning, deep learning, intelligence system, computational intelligence. They confuse what for. Now it is not limited to computer science and engineering department. It is now limited to all branches of engineering, science, and management. everybody is using machine learning and deep learning. I will clarify very, very fundamental things during the course of my talk. I will speak something on computational intelligence, where from all this intelligence has come. Then I will speak some of the fundamental AI machine learning techniques and their various applications. Then I will speak something on deep learning, biologically inspired technique, and some of the machine learning techniques. Let us see how much I can able to cover during these 2 hours of lecture. So part 1, intelligent data analysis. Let's see. Datum. Datum is singular. Data is plural. We collect data. Data is collected from various sources by experiments through communication system, agricultural data, finance data, political data, weather data. So we collect a large amount of data, and these data are so vast, we cannot arrive at a decision. We cannot visualize, but we cannot make an analysis by conventional method to arrive at a decision. Why? You want to take a decision. A doctor wants to take a decision. A financial expert wants to take a decision. For this reason, they have to use this machine learning, deep learning, computational intelligence technique. Just like our brain can take a decision, human beings are the most sophisticated computer also cannot take a decision. We have to take the help of intelligent methods to make a decision. For reasoning, we have to reason out why you like this, why you did not like this. Reasoning to arrive at a solution. So for all these things, analysis of data are essential today. Data analysis are of 2 types. 2 types of data analysis. One is fundamentally based on statistical operation research methods. The second one, which I'll be talking today, is the intelligent based on computational intelligence technique, which comprises of what is computational intelligence, artificial intelligence, machine learning, deep learning, artificial neural network, fuzzy logic, evolutionary or biologically inspired technique. All this together helps to make a decision. These techniques can take a decision just like human brain take a decision. So these techniques are intelligent technique, cognitive techniques. Of late, because of large amount of data, big data analytics have come into picture. That is a completely specialized area. This big data analysis can be statistical based method or it can be intelligent based methods. Now, what are the various, those who are started, those who are attending and wants to pursue their PhD work or postdoctoral work or research, this will be immensely benefited. The data, we call it raw data. Data needs to be suitably transformed to be used for some applications for modeling. So first the data needs to be prepared. I can give an example. You got some vegetable from the market. The vegetable to be cleaned. The vegetable has to be cut to suitable size. Then you can use that vegetable to make some curry. Therefore, pre-processing of making a curry is getting vegetable, washing it, cleaning it, and chopping it to the suitable size. This is called pre-processing. So data need not be fed into any intelligent model for direct analysis. It is wrong. Therefore, the data needs to be pre-processed. What are the different steps of pre-processing of the data? First one, missing data. Those who will be doing research, carrying out research, they must have faced that some of the data was available, but data is missing, either during storing or during transmission or during experiments. How to reconstruct, how to generate the missing data is an important area of research. Out of say 200 data, 10 data are missing. They may be very significant, they may be very important. How to reconstruct, how to recreate this missing data. This is a research area. Many people forget during classification and forecasting or clustering to normalize the data. What do you mean by normalization of data? I'll give an example. Suppose you have 100 samples of data. Some data is very large, some data is very small. The small magnitude data may be important, but when you fit to the model, when you give as input to the model, small magnitude data, they do not contribute, but they are significant. How to give emphasis, how to give weightage to the small data? That reason you need normalization. There are many methods of normalization. I'll give an example. Simple method of normalization is find out the maximum magnitude of the data, find out the largest data, and divide each sample of data by the highest value. This is a simple method of normalization. The data will lie between 0 to 1, but this is not a very good method of normalization. One better method of normalization is what? Find out the mean of the, you have 100 data, find out the mean of the data. Find out the variance of the data. From each sample of the data, subtract the mean and divide by the variance. That is the best method of normalization. Are you following? Are you understanding? Even researchers publishing paper and with PhD do not normalize and publish paper. It's not good. You have to normalize the data. One of the best method of normalization, which I told, calculate the mean of the whole set of data. Calculate the variance of the whole set of data. From each sample of data, subtract the mean and divide by the variance. This is one type of normalization. After you do the reconstruction of the missing data, after you normalize the data, then you have to extract the feature, the important hidden information from the data. Why do you extract the features? Why do you extract the feature? Interactive class would have been very nice. I could have asked question and listened from horse's mouth. Unfortunately, this is an online class. Feature extraction is redundancy reduction. Those who are not important, who do not contribute to the output, need to be removed. Feature. I'll give an example. I always give some example. Try to understand. I am a person, my face is to be recognized. I put a specs. I have a black mole on the right side of my forehead. I am little bald-headed. 3 features on my face. I am bald-headed. I have a mole on the right side. forehead, top corner, I use specs. These are the distinguishing features. So from the data, how to extract the distinguishing feature? That is very important. There are three types of feature extraction. Three types. One is statistical method. The second one, transform domain method. Third one, technical features. Statistical features are, example is mean value, variance value, cumulants. Like that, the statistical features have to be extracted from the time series data. You have a set of data, calculate the mean, variance, cumulants, higher order statistics, and use them instead of the raw data. Use this statistical features as the input. Second one, which is very, very important, and most of the researchers are using today, transform domain features. What are the various transforms? There are about 50 types of transform in digital signal processing. 50 types. Discrete wavelet transform or fast Fourier transform, wavelet transform, cosine transform, S transform, Hadamard transform, Walsh transform, and so on. So if you are having a set of raw data after normalization, can make a transformation. It is a mapping from endpoint to endpoint, but the transform domain values are saline features, just like a black mole, just like spats, just like ball head. You get important hidden information. So instead of using the raw data to the model for forecasting or for classification or for clustering, you can use these features as the input, not the raw data. Do not input raw data, but in turn, you use the features as the input to the model, which have been extracted from the raw data. Am I clear? Are you able to? How many participants are listening? I don't know, but try to understand. The third type of features, which are very, very important, people neglect technical features. The technical feature relates to the types of data you are using. If you are using weather forecasting, if you are using stock market prediction, if you are using some data for communication, smart grid application, healthcare, disease prediction. So technical features are features related to the patient, related to the weather, related to the stock market. These are called technical features. So once you extract three types of features, then the amount of features become large. Am I clear? From the same data set, you are extracting three different types of features. And when you mix all the features, the number of extracted features become large. That is not correct, because these large features will take more time for the model to develop. The training time will be more, the cost of the product will be more, and the memory requirement will be more. So many disadvantages. Therefore, feature is to be reduced. Less significant features which do not contribute to the output has to be identified, and these non-significant features have to be neglected, has to be dropped, has to be removed before it is fed to the model. Are you following? Feature extraction, feature reduction. Reduction, there are 5-6 techniques. Just you can't reduce. How to know which feature is important for some application, which features will not contribute, how to distinguish. So there are methods. One is to learn these methods and try to use in your research. The another thing I want to speak very categorically Try to listen. Feature selection. One is feature extraction. Other is feature reduction. Reduce feature. If you use the model, training time becomes less. The model memory requirement becomes less. The cost becomes less. But unfortunately, the accuracy little goes down. If you use all 100 features and somebody use 40 features, the 40 features will not give the same accurate classification or forecasting as 100 features will do. But why we reduce the feature? To reduce the cost, the product cost, the training time, and the memory requirement. So far as the application is concerned, feature reduction is required. Accuracy might be little reduced. Feature selection. Suppose there are 100 features. You are not reducing the features from 100 to 40 or 50. Some of the significant features you identify and retain, and less significant features has to be removed. There are methods by which you can identify the significant features. Less significant features can be known and can be neglected. So 3 things I told you. Feature extraction, feature reduction, and feature selection. Try to understand. Those who want to do research, do not use blindly. You all participants, perhaps being from computer science and engineering domain, it is my appeal to you. Try to understand the various method and find out the best suitable method of feature extraction, selection, and reduction in your research. Each one I can talk for hours. Feature selection, I can give a lecture for 2 hours. Similarly, feature reduction and features creation. Feature reduction techniques are factor analysis, principal component analysis, linear discriminant analysis. There are many techniques as in today which have been reported for feature reduction. Try to learn, use in your research. Without reduction and with reduction, see the performance of classification, accuracy of classification, or accuracy of prediction, and compare. I hope you are understanding. You are trying to put your effort to learn. Am I clear? Let's go to the next slide. See. Yeah. This is the most important slide in my 110 slides. The most important. Please look. Please try to. You know everybody, many people are publishing, many teachers might be attending, lecturing. Try to understand this important, most important slide of the whole of my talk. Now, people from all domains, science, engineering, and management, they are now crazy to use machine learning, deep learning, biologically inspired technique, artificial neural network, fuzzy logics are in essence all belong to the domain of computational intelligence. But why? What operation they do? There are, if you look to, there are 8 types of operations. Whole data science. Whoever is doing research in the world, they perform one of the 8 tasks. There is no 9 tasks. 8 tasks. Some people perform intelligent filtering. Some people do research on application on clustering. Clustering, filtering. Clustering means grouping. Grouping. Third operation, forecasting or prediction. Fifth operation, Fourth operation is classification, filtering, clustering, forecasting, and classification. Four. Fifth one, which is used for control application, used for pattern recognition, used for many hundreds of applications, whether it is geophysics, mining, management, finance, electrical engineering, computer science, maybe security, whatever area. You have to estimate the parameter. Parameters are extract, estimate to know about the behavior of the physical system. The parameter says about the behavior of the physical system. Physical system, there are two. One system is healthy, other system is weak. These parameters will tell which one is weak, which one is strong. I'll give an example. There is a furnace. Furnace is running nicely. There is another furnace. That furnace is giving a lot of trouble. You model both the furnace. They are electromechanical device. But I can make a electrical model of the physical furnace, whether it is a motor or a fan, or whether it is a furnace, whether it is a building, smart building, I can make a model. And this healthy model, the parameter of the healthy furnace and the parameter of the defective furnace, these parameters you compare. From the parameter, you can able to identify what is the problem in the defective furnace. What is the problem? You can identify the fault and you can rectify it. Most important today, whether it is smart city, smart industry, smart grid, smart agriculture, everywhere we require estimation of the parameter, system identification, pattern recognition, or direct modeling. Their name is same. The second one, inverse modeling, deconvolution, channel equalization, non-linearity compensation. This is another area, a very vast area. I'll give one or two examples. We talk of IoT today. We talk of smart sensor. We talk of intelligent sensor. This sensor, if it is intelligent, if the sensor itself malfunction, the intelligent sensor automatically rectify it to give always the correct reading. I'll give an example. I'm not feeling well today. What I do? If I'm feeling cold and fever, I've got some tablet I take. If I'm still feeling very bad, I go to the doctor. I'll not go to my office and doctor prescribes some medicine, make some test, and I become better. So from a defective sensor, automatically by going to a doctor or taking tablet, I become smart. Similarly, a sensor itself will find or diagnose the fault. The filter or the meter or a device or a motor will itself find the defect. And the motor, being intelligent, will rectify the fault. This is the world we are going for this. Self-identification of the types of fault by a physical device which doesn't have life, and the rectifying by itself. If these two features are incorporated to a system, that system becomes smart, that communication system becomes cognitive, or that control becomes intelligent control. Fantastic. So inverse modeling has a potential application. Actually, you should listen hours and hours talk on this inverse modeling or parameter estimation or direct modeling. Time is not there. The next important operation is called optimization. Today, optimization has become the essence or the fundamental of all branches of engineering and science. What do you mean by optimization? You have got 500 rupees managed for the whole week. Since the money is less, you have to optimize how much petrol, how much I'll purchase, commodity, how much vegetable. Because the money is less, you have to optimize so that your money will last up to the end of the month. Optimization comprises of two things, maximization and minimization. Today, that particular thing to be minimized or maximized can be of single variable or can be of multi-variable. I'll give an example. Y is a function of x. Y is a function of x. Let us say sin x. Find out the value of x at which sin x is maximum or sin x is minimum. We know that when x is equal to 0, sin x is 0. When x is equal to pi by 2, the value is 1. That is the highest value. Then to find the value of 0 or pi by 2 is optimization, maximization or minimum. For a single variable, it is very easy. But y is a function of two variables. Y is a function of x1 and x2. There is a function sin pi x1 plus e to the power minus pi x2. There is a two variable problem. Find out the combination of x1 and x2 such that y will be either maximum or y will be minimum. This is a multivariable. It becomes difficult. You have to take the percentage. If y is a function of 30 variable, find out the maximum value of y or minimum value of y and what is the magnitude of each of the variable. It's a very difficult problem. So when it becomes a multivariable, then to get the actual magnitude and the true value is very difficult. The other types of problem is single objective, two objectives, or multi-objectives. I'll give an example. I'll make a product. This product, weight to be less. The weight of this product will be less. The durability of the product will be more. And the price will be less. Price will be less. Durability will be maximum. How to achieve all these objectives? These are diversified objectives. Price will be less, duration will be much, and weight should be less. To solve such types of problems are called multi-objective optimization. When you make to the commercial market, we have to make a product which price is less. The car will be sold at less price, but the car consumption will be also less. Price will be less and durability should be high. So in every domain of human life, multi-objective optimization play a very important role. How to solve? Again, each of these variables, x1, x2, x3, has a limit. x1 lies between 0 to 1, upper bound and lower bound. x2 lies between -5 to +5. x3 lies between 0 to 100. So when the limits of each of the variables have been given, which are called constraint on the variable, how to optimize? Remember today, multi-variable, multi-object, multi-constraint optimization is the future. It is being used in almost all applications. Thanks to nature inspired, thanks to biologically inspired, thanks to evolutionary component. which are part of the computational intelligence, which actually solve this problem. The behavior of the bird, the behavior of the insects, the behavior of any of the animals are the example how they are solving each of them, each like a honeybee. Let us take fish. They survive from years to years. They do not die. Either in the good time or in the bad time, they share each other. And they are this collective behavior. Try to learn collective behavior, distributed learn, cooperative phenomena has given rise to this set of algorithms, and that algorithms are called biological inspired. Starting from genetic algorithm, particle swarm optimization, and colony optimization, honeybee algorithm, and so on. Today, to the best of my knowledge, about 70, 80 types of biological inspired technique or natural inspired technique have come to the world. Every technique has their own merits and demerits. How to use these techniques for successfully achieving the highest or lowest win. The last one is detection. What is detection? Suppose there is 100 watt, one signal is 100 watt, another signal, another noise is 1 watt. So noise is small, signal is large. Very easy to remove the noise or ignore the noise. Let us take the reverse. Your signal is 1 watt, but the noise is 100 watt. That is, we call it SNR is very poor. Signal to noise ratio is very poor. How to extract that very feeble or very small signal which is buried under noise. I call it buried under noise. Extremely difficult task. And that technique is called detection. Today, one aeroplane is coming in the aerodrome. They are receiving the signal. If it is noisy and SNR is poor, you can't detect whether aeroplane is coming or not. Whether aeroplane belongs to friend country or foe country. After how much time the aeroplane will reach the aerodrome. Similarly, suppose there is somewhere inside, underneath the water. At what depth the submarine is there? Submarine is moving or steady, stationary. Submarine belongs to friend country or a foe country. It belongs to India or it belongs to China. How to detect? That is called detection. So detection is another important operation. So today I told you, whether you are reading science, engineering, any branch of engineering, any branch of science, any discipline of management, only this is the whole data science. This is what we call the method which are solved. These 8 methods of filtering, clustering, forecasting, classification, parameter estimation, inverse modeling, optimization, and detection. There is no 9th one. Whole data science, machine learning, artificial intelligence, deep learning, computational intelligence, try to solve any one or two. All the research, any of you or me, I've guided 50 PhDs. They belong to one of these work. Either one of these or 2 of them are being used to solve using all the artificial intelligence techniques. I spend a little more time, but this is the most fundamental. If you understand this, you can pursue your research in a very, very efficient way with a lot of publication. Next slide. Now, for solving each of these techniques, there are various methods. I'll give some example on filtering can be performed by least mean square, recursively square, back propagation learning, etc. Feature reduction, as I told, principal component analysis, LD, clustering or grouping, K means hierarchical clustering, fuzzy C means intelligent, biologically inspired based clustering. So these are the set of techniques for each of the 8 operations which are being used for solving the problem. So first thing you have to learn, your research area pertains to which one or two aspects of these 8 techniques that you have to identify. Second, for each of the techniques, there are methods. For example, for classification, all regressions, neurophagy techniques, artificial neural network, net-based, decision tree, random forest, support vector machine, etc. So for these techniques, you have to learn and apply. Yes. Can I give a gap for half a minute? Just half. Okay, let's start. A system today can be of 3 types. Fixed system. A filter is fixed once designed. A car is fixed. A building is fixed. But these systems are not adaptable. When a physical systems are merged with a software-based system, both combination of hardware and software, the system can be adaptable. Adaptive system, adaptive filter, adaptive control can adapt itself. There is a malfunctioning. If the performance is degraded, the system itself can adapt. Then what is intelligent system? Intelligent system is above adaptive system. It can able to find the fault. It can able to find the fault or the defect. And then it try to rectify the fault, just like our human being does. If an adaptive system has the potentiality to find the fault and then adapt, if both the features are incorporated, that system becomes intelligent system, smart system, or cognitive systems. Now the computational intelligence, as I was telling, artificial neural network, it comes CI, comprises of artificial neural network. And these about 20 types of artificial neural network have been reported, right? From perceptron, multi-layer neural network, functional link artificial neural network, radial basis function neural network, recurrent neural network, applet spiking neural network, applet spiking neural network. I don't think any of you have heard of this. This is the latest development. The brain modeling of the brain we try to do by multi-layer artificial neural, which is wrong. It is not exactly the modeling. People try to study the brain science and they found between the 2 neurons, the propagation takes place through spikes, not through connecting weights. Wrong. That is through spikes. The height of the spike and the generation of the spike, when the distance between the spike and the height of the spike constitute the intelligence. When the spike will generate, after how much time another spike will generate, that is similar to the weight of the connecting weight. We try to update the weight by back propagation line. Here, the spike occurrence has to be variable, and you have to find a short-tempered person, the number of spikes and the duration of the spikes are different than a cool person, a dull person, and an intelligent person. The spikes behavior represent why somebody is intelligent, why somebody is dull, why somebody is emotional, why somebody is hard in his heart. The behavior of the person are being studied, and spiking neural network is an important model. Try to. I'll tell some other thing. Spiking neural network. Can you make a short-tempered person a cool person? Can you make a dull person an intelligent person? By reading this more detail about spiking neural network and then doing a lot of research on this, people are trying to understand the behavior of the person. Of course, convolution neural network is a deep learning network. Like that, there are hundreds of such network has come to in the field of computational intelligence. But the most important part is the 6 and 7 one spiking neural network and CNN. These types of neural network has two phases of operation. Two phases. First one, you have to train the model, just like a robot, just like a small child has to be trained. Once the child trained, the child can perform the same task. The robot also, whatever you are training, the robot can do the same thing repeatedly. This is called training phase. After training phase, it is followed by validation or testing phase. Whether it is trained properly or not, you have to validate and find, you have to assess the performance and are you satisfied with the developed model. And then if these two stages are passed, then that particular model, developed model can be used in real life application, in practical application. The learning is of three types. One is supervised learning. I am teaching, you are listening, supervised. Mother teaches, mother shows what to do, what not to do. The child learns from the mother. The school teacher teaches, the college teacher teaches. This is supervised learning. No teacher is there. No mother is there. The child also learns by self. That is unsupervised learning. So our brain has the potentiality of both supervised and unsupervised. If you are interested, try to learn. There are very less research on unsupervised learning or back propagation learning or any such learning as supervised learning. I'll give an example. A person wants to be a good cook. He took training under experienced cook. I want to learn car driving. I took the help of a company who sent me an experienced driver who I learned. These are supervised learning. I bought a car. Nobody helped me, but I learned by myself. There will be a lot of mistake, maybe minor accident. Finally, I learned. This is unsupervised. The third type of learning is called reinforcement learning. These types of learning, you train it, agent, you make another artificial agent, you first train the agent. Agent may be wrongly trained or properly trained. The agent will again help you to train. You train the agent will train it. These types of reinforcement learning has a high future. I'll give an example. There are 10 rooms in a building. In a building, how many rooms? 10 rooms. And in one of these rooms, all rooms are open. You put some fish and you allow a cat. You leave a cat. What the cat will do? Cat will search for food. It moves from room to room. I don't know how it goes, but finally, very fast, it will go to the room in which fish is there. These types of learning is called reinforcement learning. So 3 days in your research, try to utilize reinforcement learning, unsupervised. If you use the conventional learning, then there is no novelty. Therefore, for pursuing research, these aspects has to be learned. Now I'll give the lecture. It is now 8:15. Meenakshi, should you give up 10 minutes? I'll go to deep learning. I'll go to the application of this deep learning and machine learning. Should I? Will you give gap of 10 minutes, Meenakshi, or should I continue? Can you send a message in the chat box?
Yes, sir. We can take a break of 10 minutes and then
Should I
after that we
continue
can.
or give a gap of 5 minutes for the participant to start another aspect of my lecture?
Yes, sir. We can take a break of 10 minutes.
Okay, 10 minutes break. Thank you.
I request all the participants to have a break of 10 minutes. We'll be back in the meeting after 10 minutes.
म्यूट करते हैं म्यूट म्यूट में पूरा कंटिन्यूस